what kind of products you are producing, or what kind of processes are being carried out, the required conditions will be varying. Some of the examples are textile industries. Textile is one of the oldest users of air conditioning. The yarn used in a textile is very sensitive to temperature and humidity. So, if you want to have a very high output, you have to maintain the humidity and temperature within certain limits, so that the yarn can move at high speeds without breaking. This is the reason why it was used early in the early days, and how the output was increased using an air conditioning system. And air conditioning is also required in printing presses. In printing presses, what happens is, typically, for example, if you look at a color printing press, the ink will be deposited in stages. So, and when the paper moves from one stage to the other stage, the ink has to dry off before it reaches the other stage. For example, let us say that first stage you are depositing red ink, and next stage is black ink. By the time the paper moves from the red ink stage to the black ink stage, the ink has to dry. If it does not dry, then there will be problems, and there will be mixing of the colors and all. So, you have to again maintain certain humidity, so that drying can take place within the required time. So, all printing presses require very good air conditioning systems, and also the paper used is sensitive to the humidity. So, you have to maintain humidity in certain levels, so that the paper can you can prevent the curling of the paper, etc. And as I mentioned already, refrigeration is also required, or air conditioning is also required in manufacturing of several precision parts. And this is particularly so in case of watches, wrist watches, or in case of semiconductor elements and all, where the cleanliness, temperature and humidity are very, very important. For example, if the humidity is not right, and if the people start sweating, and when they handle the parts with sweating hands, then water gets deposited on the parts, which may lead to rusting. Since here the dimensional accuracy is very, very important, you have to prevent any variation in the dimensional accuracy. That means you have to maintain both temperature as well as humidity. And in fact, all electronic industries, semiconductor making industries and other electronic industries, the air conditioning is a very, very critical requirement. And in those industries, in addition to the temperature and humidity, the cleanliness of air is also very, very important. That means there should not be any dust particles or any other solid particulates in the air. So, in addition to a good air conditioning system, they also have a variety of filtration equipment, which will be filtering air and provides clean air to the conditioned space. Then as I said, semiconductor industries is one of the largest users of air conditioning. And in pharmaceuticals, several pharmaceuticals involve several chemical reactions and all, and they require controlled conditions of temperature and humidity. So, when they are being produced and when they are being stored, you require certain temperatures and humidity. In fact, you might have seen on many of the medicine bottles and all, they write that store in a cool and dry place. That means the medicine is sensitive to temperature. You have to store it in a cool place, and it is also sensitive to moisture. That is why they say cool and dry. Then photographic materials. Photographic materials are also very sensitive to moisture and to some extent to temperature also. So, again they require air conditioning. In fact, if you remember, Eastman Kodak is the first company to use air conditioning for storing its photographic products way back in 1900s. And air conditioning is very much required in computer rooms, especially in large computer centers and all. There is a large amount of heat rejection, so which has got to be taken out. So, you require an air conditioning system. Also, in large computer centers, there will be a lot of heat generation because of people, so which also needs to be taken out. So, all computer centers require good air conditioning systems. Also, the computer centers require clean air also, because you should not have any dust particles floating around. So, typically you have to maintain not only the temperature and humidity, but also the cleanliness of air. Then air conditioning is also required in mines. For example, mines, as you go down, the temperature will increase, so it will be terribly hot underground and inside the mines, and for the workers, they have to do hard work inside the mines. That means they will be rejecting lot of heat, and outside temperature is very hot, very high, and a lot of heat generation is there. Then if air conditioning is not provided, then the miner will be subjected to what is known as heat stress, and he cannot work properly. So all mines require good air conditioning. And another important requirement is the air conditioning systems for mines have to provide fresh air also. That means ventilation is also important. So you have to again have systems which can provide the right temperature conditions and also the right amount of ventilation inside the mines. And air conditioning is also required in large power plants. In large power plants, inside conditions will be typically hot because the presence of boilers and other equipments, etc. So the workers will be generally under some heat stress. So you have to provide some amount of comfort by way of air conditioning. This is also true in case of say steel industries. Steel industries also inside conditions will be very harsh. So you have to have some kind of an air conditioning system. One problem with large power plants or steel mills, etc., is it is not possible to air conditioning the entire power plant, or you cannot air conditioning an entire steel mill. That's not commercially feasible. So what you have to do, or what is generally done, is they resort to what is known as spot cooling. That means certain areas where the workers are, only those areas are cool and the rest of the areas are not cool. So this is what is known as spot cooling. So by using spot cooling, you can provide some measure of comfort to the workers. Now let us look at one very important aspect of air conditioning, what is known as indoor air quality. We will see in later lectures that an air conditioning system, the energy consumption of an air conditioning system depends upon how much amount of fresh air or how much amount of ventilation that you are providing. So in the olden days, to reduce the energy consumption, what people used to do is they used to reduce the amount of fresh air. That means they used to recirculate the same air again and again so as to reduce the energy consumption. But later it was observed that people who were spending lot of time in air conditioning buildings were suffering from several problems, and this is known as the sick building syndrome. That means people working in air conditioning buildings experience certain sicknesses, and this is known as sick building syndrome. And later they found that not only temperature and humidity and air motion, but also the quality of air that you are supplying to a conditioned space is very, very important. This is even more so in nowadays because people are spending a large part of their lives inside the buildings. It is estimated that about 80% of the time is spent in conditioned space. So if the conditioned space is not clean and the air quality is not good, then people will fall sick. As a result of which, as a separate branch of air conditioning, this indoor air quality, or IAQ, it's called as IAQ, has emerged as a separate branch of air conditioning, and it requires different techniques and all to ensure air quality. So this is one pertinent and important issue of indoor air quality. And as I said, any air conditioning system must provide not only required temperatures and all, but also clean and healthy environments. In the olden days, people were very sure that an air conditioned space provides comfort, but they were not really sure whether it is good for health or not. And subsequent studies have shown that if you don't design an air conditioning system, in fact it can be very unhealthy. So nowadays the emphasis is not only on comfort but also on healthy environment. So this is the area which is dealt with by IAQ, or indoor air quality. As I mentioned, the sick building syndrome is very common in especially in places where the outside air is dirty and the designer of air conditioning system provides very less ventilation to save energy. So in the materials used, typically the indoor air quality depends on the amount of ventilation that is provided, and what is the quality of outside air or the fresh air that you are supplying, and also the what kind of materials you are using inside the conditioned space. So these three parameters decide whether an environment is healthy or not. and generally any indoor air quality study recommends the required ventilation qualities, and also recommends what kind of materials should be used within the conditioned space, and how to treat the air. The fresh air, outside air itself may be dirty, then you have to treat the air before you supply it to the conditioned space. So all these aspects come under the indoor air quality. Now let us look at another very important issue, that is energy. All air conditioning systems consume a large amount of energy, and now because of the requirements in all industries and in many office places, residences, etc., the installed air conditioning capacity is increasing tremendously, and all these systems require energy, so the energy consumption by the air conditioning systems is also increasing tremendously. And in the olden days, people did not care much for the energy consumption of air conditioning systems. So they were designing the systems without optimizing them. As a result, they were consuming a lot of energy. So nowadays the focus has shifted. Now people say that they want a system which provides not only comfort but which is also energy efficient. So this is second issue of any air conditioning system. So energy efficiency has to be guaranteed by the supplier and by the designer. And the energy efficiency of any air conditioning system depends not only on the air conditioning system but also on other factors. Let us see what are the factors which decide the energy efficiency of an air conditioning system. It depends upon the design of the air conditioned building itself. For example, if the building is not designed to suit properly, then it will consume a lot of energy. And one nowadays you might have seen that a lot of people use a lot of glass. So use of glass actually is will lead to larger loads on air conditioning system. That means you require a bigger air conditioning system, which will ultimately lead to larger energy consumption. So here the architect has a role to play. So the architect along with the air conditioning engineer has to do the complete system design so that the total energy consumption is reduced. And people also use names like intelligent buildings, etc., with reference to the energy consumption. And the second important aspect is selection of suitable refrigerant systems. All refrigerant systems are not equally good for all applications. So you have to, depending upon your requirement, you have to select a suitable refrigerant systems. For example, there are in areas where you have lot of waste heat is available, then it makes sense to select a vapor absorption system which uses the waste heat and not an electrical energy or mechanical energy. So depending upon the situation, you have to select a required refrigerant system. And the third factor is the selection of suitable indoor conditions. As I mentioned, as I have shown, the optimum indoor temperature varies from anywhere between 20 to 27 or 26 degrees centigrade. And you will see later that if you are trying to maintain lower temperature inside the conditioned space, that will lead to higher energy consumption. That means a lower conditioned space temperature means in general higher energy consumption. So if it is not absolutely required, we must try to keep the temperature on the higher side to reduce the energy consumption. And several factors again come into picture here. For example, you are designing an air conditioning system for summer, and it's a typical office building, let's say, and everybody in the office is wearing very heavy clothing. So as I mentioned, if everybody is wearing heavy clothing like suits, etc., then you have to maintain lower conditioned space temperature so that he can reject the heat. That means lower temperature in the conditioned space and higher energy consumption. And if the same person is wearing light clothing, then you can have a higher temperature in the conditioned space, and thereby you can reduce the energy consumption. So the selection of suitable temperature, this is also very important. Of course, sometimes this can be a psychological aspect also. People may think that lower temperature is better, but it is a job of the air conditioning engineer to convince that it's not necessarily so, and the required comfort temperature is not a single point, but it's a range. And selection of suitable controls. You can also reduce the energy consumption of an air conditioning building by using suitable controls. For example, if you have an air conditioning system which uses a variable speed compressor, so you can reduce the energy consumption using an efficient variable speed compressor. So you require a control which will be able to vary the compressor speed. And then other aspect is the use of thermal energy storage systems. The concept here is like this. There are many places where the night temperature can be very low and the day temperature can be very high. For example, places like deserts where nights are very cold and days are very hot. So in such cases, you can use the concept of thermal energy storage. That means you can store the cold in the night and you can use the part of it to offset the heating in the daytime. In fact, this is also the reason why old buildings like old temples, forts, etc., they are comfortable even in summer, because there the walls are so thick that they store a lot of thermal energy and thereby they provide comfort even without any artificial air conditioning system. So the thermal energy storage can be provided by way of the walls itself, or you can also have other means of providing thermal energy storage. So these are the ways by which you can control the energy consumption and improve the energy efficiency of an air conditioning system. Now let us conclude this lesson. We have seen that the scope of refrigeration and air conditioning is really very wide and the applications are very diverse. It has grown tremendously thanks to the efforts of thousands of scientists and engineers over a period of say 100 to 150 years. So it's not the result of a single man's effort, but it's the effort of many people. And right now, as I mentioned, the issues of concern are first is energy efficiency, and second important issue is eco-friendliness. That means the refrigerant systems that you are using should be eco-friendly. They should not create any damage in the environment. These are the important concerns, and people are working on to develop systems which are both eco-friendly as well as energy efficient. Thank you, and based on this lesson I have given some questions. The answers to this will be provided in subsequent lessons. Thank you.